All right, we're going to talk about implicit differentiation. So these are kind of the steps that we're going to use when we're doing implicit differentiation. So we're going to differentiate both sides of the equation with respect to x, treating y as differentiable function of x. Okay? Then we're going to solve for dy dx. All right? So this is what happens is now we have a function that has y's in it, and it's just not just a single y where it becomes y prime or dy dx. Okay, so what we're going to do is we're going to take the derivative essentially of both sides. Okay, and so what happens here is this becomes 2y dy dx, because that y prime, remember that y prime is dy dx. This becomes 1, the derivative of x is 1. Then I'm going to divide by 2y. And I get dy dx equals 1 over 2y. And there's my differentiable, my implicit differentiation of y squared equals x. So here's my next one. This is why we want to be able to solve for dy dx. So I have y squared plus x squared plus sine of xy. The first thing I'm going to do is take the derivative of this. So this gives me 2y dy dx plus 2x plus plus cosine of xy times, now I have the derivative of this, right? So this is x times y. So this is the product rule. So I have the derivative of the, I have the first times the derivative of the second, dy dx, plus the second, y, times the derivative of the first, which is just 1. Okay? So now I need to get this to where I have my, and this was equal to 0 here. And I need to get this to where that I can solve this for dy dx. Oh, actually, that wasn't equal to 0. This is the equal sign right here. Sorry, I miswrote that. All right, so now I'm just going to do a little simplifying here. 2 dy dx equals 2x. I'm going to take this cosine here, so this becomes plus x cosine xy dy dx plus y cosine of xy. Okay? So I need to move this cosine to the other side. So now I have 2y minus, and rewrite this. Okay? Okay, I have 2y minus x cosine of xy dy dx equals 2x plus y cosine of xy. So this one's a little bit harder because we had the chain rule here with the product. And now I'm going to solve for dy dx. So I'm going to divide everything by this. So I have 2x plus y cosine of xy all over 2y minus x cosine of xy. Okay? So now what happens if I want to take a second derivative? Well, you're still going to take that derivative here. So now what I'm going to do here is I'm going to take the derivative here. So this gives me 6x squared minus 6y dy dx. Actually, I'm just going to leave it as y prime equals 0. So now when I solve this, I have y prime equals negative 6x squared over negative 6y, which gives me x squared over y. Okay? Now, I need to take this derivative again. So now I'm going to take the second derivative. So y double prime is the derivative of this. So I have y times 2x minus x squared y prime over y squared. Well, I actually can take in and plug in what y prime is, because I have what y prime is here. So now I have y times 2x minus x squared times y prime. Well, y prime was x squared over y all over y squared. Okay. And so I could simplify this out a little bit here. 2xy minus x to the fourth over y all over y squared. One more time. So 2xy y squared minus x to the fourth over y cubed. Okay, so there's my piece there. The next one is here's our function of x cubed plus y cubed minus 9xy equals, it's actually equal to 0. That is a point on that. It asks me to find the tangent line of the point 24. So the first thing I need to do is find my derivative. Remember, my derivative gives me my slope. So I have 3x squared plus 3y squared dy dx minus 9 x dy dx minus 9y equals 0. Okay, so I'm going to move everything to the other side except for my dy dx. So I have 3y squared minus 9x dy dx equals, I'm going to subtract off my 3x squared plus 9y. Now I'm going to divide by 3y squared minus 9x. Okay, and I get dy dx equals negative 3x squared plus 9y over 3y squared minus 9x. Now I'm going to plug in 2 and 4 into this, okay, to find my piece here. So I'm going to plug in negative 3, 2 squared plus 9 times 4 over 3 times 4 squared minus 9 times 2. So that gives me negative 12 plus 36 over, what is this, 1648 minus 18, which gives me 24 over 30, which reduces to 4/5. Okay, there's my slope. So now I can just put y minus 4 equals 4/5 x minus 2. That's in point slope. I can leave it like that. If I wanted y equals mx plus b, I could solve this. Y equals 4/5 x minus 8/5 plus 20/5, which gives me y equals 4/5 x plus 12/5. There's the equation of my tangent line. So when you're doing implicit differentiation, just remember you're still going to take that function of y, you're going to take the derivative of it, okay? Just like you would if it was an x. But when you take the derivative, you need to keep that dy dx in there because it's saying that, hey, there's this function y that's in regards to x. We're taking it, the derivative of y with regards to x.